Welcome to lesson 3.9, day 2. Again, we're finding the derivative of exponential and logarithmic functions. Today, we're not really learning any new rules or specific derivatives, but we're just using finding more ways to use them in more problems that they are in. So this first problem is an example of an e function times a natural log function. And since we have a function times a function, you should always think product rule. Function times a function. Product rule, and then an exclamation point. Okay, so we're going to make u equal to the ex and v equal to the ln of 3x. So u is e to the x, v is ln 3x. Now, the derivative of u, remember the derivative of e to the x is just e to the x. I have rules over here for your reference. The derivative of v, which is ln, is 1 over 3x times the derivative of the 3x. So that's a 3. Therefore, we get 1 over x. All right, we're going to multiply these together using the product rule. So we have v times u prime, which means e to the x times ln of 3x. And we add that to e to the x times 1 over x, which looks like this. All right, and that's basically your derivative. You could pull out an e to the x and rewrite it, but that's basically your answer. Second thing we need to do with these is write tangent lines. Just like with any derivative, we can write the tangent line. So we want to know what point on the graph does the tangent line have a slope of 21? So m is 21, which means that's the derivative of y has to equal 21. So we're going to use our trusty exponential formula here on our function y equals 2 to the t minus 3. Now I know the derivative of negative 3 is 0, so I've got that one covered. So let's check on this 2 to the t. We have our a value is 2, our u value is t, and therefore our u prime is 1. You gotta love this too. Okay, so just plug in this formula. The derivative of y equals ln of 2. I don't know why I'm writing it up in the air. ln of 2 times 2 to the t times 1. Okay? And that's our equation. So now what we want to do is set that equal to 21. Now we have to do a little fancy algebra solving. All right, we're going to divide by ln of 2, divide by ln of 2. All right, we get some number here. We have 2 to the t. This looks like ln squared. It's ln of 2, which is some number. Now, I like to leave this in this format because it's more accurate. All right, now when we solve for t, remember we have to take the log base 2 of both sides. Log base 2, log base 2 of both sides. And what that does is it makes the log cancel out and we are left with a t. So this is our answer right here. We can put that into our trusty calculator. I believe it's alpha zoom. No, alpha window. Let me try that again. Oh, there it is. Darn. Alpha window. Okay, I want number 5. All right, so this is, all you have to do is put this in. It was log base 2 of, what was it again? 21 over ln of 2. So let's make a fraction. 21 over ln of 2. I'm going to put another parenthesis there just so I don't get an error. And I think we're ready to go. Enter 4.921. Remember, we want 3 decimal points. 4.921. All right, that's the t value of the point, and that's what they were asking for in this question. The next problem is using the log derivative, and we actually need to write the tangent line. Thank goodness they gave us the point. We don't have to figure out the point. We just have to figure out the slope, which is taking the derivative. So let's look at our log function here and compare it with our equation over here for log derivatives. A equals 10, u equals 2x, and therefore the derivative of u is 2. So let's plug this into our equation. 1 over ln of 10, which is a number, times u, which is 2x, times the derivative of u, which is 2. So I'm going to put that on the top, times 2. Now notice that we can cancel out our 2's. All right, so y prime equals m, which equals 1 over ln of 10 times x. Now x in this case, because we're looking for a number of the slope, x equals 5. So m equals 1 over ln of 10, some number, times 5. All right, so put that into your calculator. Alpha, y equals, enter, 1 over ln of 10, ln of 10 times 5. And that equals 0.086. Remember, you can truncate or you can round, either one. So I'm going to write 0.087 because I'm used to rounding. I don't know why. And let's write our equation of the line. Y minus 1 equals 0.087, which is your slope. Or you could also write this right here. That would be fine too. X minus 1. And that's the equation of your tangent line. Actually, I need to change this to a minus 5, and that will be the equation of your tangent line, because the x value is 5 and the y value is 1. Okay, next problem. This is a tricky one. Y equals x to the 3 plus pi. Now let's remember that pi is a number. All right, now we don't really need any of our fancy formulas. Remember how you take y equals x squared? Y equals x squared, the derivative of that is 2x, and you subtract 1, so 2x to the 1. That's exactly the kind of function we have here. So when we take the derivative, we take this number, because it's just a number, we move it to the front. So we have 3 plus pi, and times x to the 3 plus pi minus 1. Isn't that tricky? This looks much more complicated than it is. That's why we like it, because we're smarter than x to the 3 plus pi. All right, so 3 minus 1 is equal to 2, so this is x to the 2 plus pi. And that is your answer. Number 5, spread of a rumor. This is a fun problem because it talks about a rumor that's spread, and this is the total number of people who've heard the rumor. So many days, T is time is days, after the rumor first started to spread. So our first question says, estimate how many students first heard the rumor. Okay, so at T equals 0 days, we're going to plug that in to our equation and see what it comes out to be. 300 over 1 plus 2 to the 4 minus 0. Okay, that's 300 over 9, which I believe comes out to be 18 students. You need to round down to the lowest student because you can't have a half of a student hearing a rumor. All right, how fast is the rumor spreading? Okay, how fast is the rumor spreading? This is at rate of change, rate of change. Therefore, we want to take the derivative of the P function, which tells the number of students. This will tell students per day. Okay, our units will be students per day. So I'm going to rewrite this function in order to take the derivative. I'll rewrite it 300, 1 plus 2 to the 4 minus t to the negative 1. All right, I'm going to have to use the chain rule on this. This is just a constant in front of it. So there's no product rule. That's a constant, not a function. So there's no product rule, but I will have to use this trusty formula. which is why I put it up there. And let's see what happens. Okay, so we have 300, and we're going to take the derivative of the outside. Our 300 is just going to be multiplied times everything. So if we take the derivative of the outside, we multiply times a -1, and then we subtract another 1, which means -2. And then we take the derivative of the inside. Okay, the derivative of the inside is where we're going to have to use this fancy-dancy formula. So, A equals 2, U equals 4 minus T, and U prime equals a -1. We're taking the derivative of U with respect to T. So the derivative of that is -1. So let's write down what we end up with here. Ln of 2 times 2 to the 4 minus T times a -1. All right? And let's, we can multiply this out, I guess, or you can just start plugging in 4, okay? Because that's what we want to know is when 4 is. I am going to do one thing. I have a -1 down here. Let's make that positive and make this positive. All right, so let's plug in the derivative at 4 and see what we get. 300 times 1 plus 4 minus 4 is 0. Anything to the 0 power is equal to 1 to the -2 times ln of 2 and times 2 to the 4 minus 1. Or, I'm sorry, 4 minus 0, which is 2, or 4 minus 4, which is 2 to the 0. Oh, so that's just a 1. Okay, so let's rewrite this one more time. 300 ln of 2. Right here I have, and then this is a 1. This is just a 1. So 1 plus 1, which means this is 2 raised to the second power. I moved it across the line and changed the sign of the exponent. All right, so if you put this in your trusty calculator and figure it out, you should get 52 students per day. That's your rate at T equals 4 days. Rumors spread quickly. And that's the end of section 3.9, day 2. Oops, I was just kidding. There's one more because this one's on your assignment and everyone always asks me about this one. So I thought it would be good to include it on this video. Okay, so this is a really good kind of challenge problem, I think, and this is a typical problem that would be on an AP test. A line with slope m passes through the origin and is tangent to y. You're not given this pretty picture that I drew, but I just drew a picture of a sample y graph and its tangent line. Okay, so we need to know the value of m. All right, so we know a couple things here. We know that the derivative of this function is equal to m. So why don't we take the derivative, see what happens there. All right, the derivative of ln, I have it listed over here again for your reference, 1 over u, which is 1/3 x, or x over 3, and u prime is just equal to 1/3. So 1 over u is x over 3, and that would be times 1/3. Okay, now if we simplify this, what happens to all this stuff? I think our 3's cancel out. And it's equal to 1 over x. Actually, I know that they cancel out. So the slope is equal to 1 over x. We also know something about a slope formula, I think. y2 minus y1 over x2 minus x1 equals 1 over x, which is our derivative, m, right? Okay, so we know 1x and we don't know the other one. True? Although we know that this is y, and so one point would be x ln of x over 3. So this is our point right here. We're going to plug that into our slope formula, and calculate what x is, because that gets rid of all of our other variables. Isn't this trippy and cool? So we have 0.1 and 0.2, which we're going to find the slope. So ln of x over 3 minus 0 over x minus 0 equals 1 over x. If you cancel out your x's, your equation now reads ln of x over 3 equals 1. Remember we're going to have to exponentiate with e in order to solve an ln problem. So both of these are going to become powers of e. So these cancel out. We have x over 3 equals e, and therefore x equals 3 times e. All right, so that's what x is. What was the actual question? What's the value of m? All right, we have x. The value of m is 1 over x. Remember, back here? So m equals 1 over 3e. That is the answer to your question. And that is the greatest problem ever. I love it. The end of section 3.9, day 2.